Good afternoon, everyone. My name is Maria Teresa Pereira, and thanks for having me today. At the end of this talk, I hope we will have the answer for this $1 million question: how to identify all the APIs hidden in plain sight. During the talk, I will also address how to document these APIs properly. But first, I'm going to introduce myself. Currently, I am a senior IT advisor / Pentester at KPMG Portugal. Here I belong to the offensive team, so the vast majority of my projects are pen tests and red teams. I had my first contact with APIs back in 2017 while I was still at university, but I only got engaged in API hacking since last year. Besides cybersecurity, some of my past experiences include process automation and backend development. APIs are the heart of the ongoing enterprise digital transformation, acting as channels for communication and data exchange between different software systems and IoT devices. So, to properly secure APIs, we must consider three pillars: governance, testing, and monitoring. API inventory is an integral part of API governance and security. Basically, it provides the foundation for you to understand, manage, and secure the APIs within your organization. By maintaining a well-organized API inventory, organizations can implement effective security controls to protect their data in an API-driven environment. Having said that, today we'll focus on the first pillar of API security, governance. One might think that inventory management is an old hat, but in the world of cybersecurity, there is one ultimate truth that applies in every scenario. You can't secure what you can't see. This is where the creation and maintenance of an API inventory comes in. APIs come in many shapes and sizes, and to create a proper inventory, we need to catalog and classify them according to their risk. An API inventory is an up-to-date, structured, and centralized catalog of all the external and internal APIs used within your organization. There are some key components that an API inventory should include, namely information about each API, such as the name, the description, the purpose, the owner, any version, any details on the version, including changes, updates. If you have any integration with third-party APIs, you should also include that information as well. Information on the API endpoints, the purpose of each endpoint, parameters, requests, responses, and of course, other API details such as authentication, authorization, dependencies, lifecycle status, data formats, among others. But why is it important to have an API inventory? APIs have long been owned and deployed by developers, often for internal use, with little to no security oversight. As APIs have become more integral to the business and now are deployed externally, the act of tracking them and securing them continues to lag in many organizations, as we can see by recent security incidents. When older API versions are not properly retired or locked down, they may have security holes that malicious actors can exploit. So by keeping an accurate API inventory and using, of course, a good version control, organizations can greatly reduce the risk of their attack surface. So by having an API inventory, you'll have a handle on your attack surface and its exposure. You can have a track of all the APIs that are used by your applications. You'll have clear visibility of who owns each one of your APIs. You can track older version of APIs. And last but not least, you can also identify zombie and shadow APIs. To show you the real importance of having an API inventory, let's see a real-world data breach. Optus is the second largest telecommunication company in Australia. On September 2022, the company had suffered a data breach, which resulted in an exposure of almost 10 million customer records. I mean, this is 1/3 of Australia's population. Some information illegally obtained after the attack was said to include names, birth dates, home addresses, passport, driving license numbers, Medicare numbers, emails, among other data. The incident unfolded as an attacker discovered an API used for testing that was unknowingly exposed to the internet using real customer data. This API, also called Shadow API, besides being exposed to the internet using real customer data, did not require any authentication or authorization. The attacker uploaded a couple of days later 10,000 customer hackers to websites and promised to leak 10,000 more each day for the next 4 days unless Optus paid a ransomware, which was $1 million in Monero, which is a cryptocurrency focused on privacy. Although a couple of days later, after posted 10,000 customer hackers, the attacker apparently had a change of heart, deleted their posts, and claimed they had also deleted the only copy that ever existed on the Optus data. The attacker apologized to Optus and said that they would have reported the security incident if Optus had made it possible to report, for example, through a disclosure program or a bug bounty program. At the end of the day, Optus said no ransom has been paid. Besides the API used for testing that was unknowingly exposed to the internet using real customer data, which you can map to improper assets management and excessive data exposure, we can add further analysis and map the other attack events to the several OWASP API Security Top 10 vulnerabilities. And here I use the 2019 version because the attack occurred on 2022 and the newer version of OWASP API Security Top 10 was only released this year, 2023. So, besides these 2 points, the API didn't have any authentication or authorization mechanisms, didn't have any rate limiting, so it allowed the attacker to exfiltrate huge amounts of data. And last but not least, the API didn't have any monitoring, so Optus didn't have a way to identify, to detect malicious activity. Now let's get to the core of this presentation, how to discover all the APIs, API discovery, or how I like to call it, API Safari. So the process that helps organizations to identify, catalog, and manage their APIs is called API discovery. API discovery often involves a combination of researching documentation, exploring developer portals, and using specialized tools in order to identify and evaluate APIs based on criteria. When it comes to API discovery, you have two methods to do this. You have the automated one and the manual one. Regarding the automated way, you'll be using specialized tools, scripts, and services in order to scan websites, applications, and network traffic for API endpoints. Here you have a bunch of tools that can help you with this task. For example, KiteRunner, Upsuite, Postman, Amass, Nuclei, Shodan, Zep, among others. Regarding the manual API discovery, you'll be reviewing documentation, and here you have OpenAPI and Swagger to help you with this task. You'll be checking for API-related URL patterns and network traffic, and here you have Wireshark to help you. You'll be analyzing source code if available, and explore API directories and ask developers, collaborating with other teams. Besides these tools that I just shared with you, another great reference that could help you in the discovery of APIs is the Mind API. This project was built by a Portuguese colleague, David Sopas, and is open source to the community. Basically, Mind API is a mind map that combines years of experience in testing API security. It is divided in two sections, reconnaissance and testing. which covers most of the OWASP API Security Top 10 and other security resources. On both, you have guidelines, links to open source tools, and documentation that can help you on the way. Well, when you are considering between manual API discovery and automated API discovery, you should always consider the advantages and disadvantages of each of them. So I enumerated some of them to help you with this task. Regarding manual API discovery, it is really suitable when you have a limited scope, when you have, for example, 20 APIs to search for. And of course, here the level of precision will be very high because you'll be carefully examining and validating each API that you found. But you have to be aware of the disadvantages as well. It is a really time-consuming task. You have always to consider to be aware of the human error, and that this task depends on expertise of the person that is performing it. Well, when it comes to automated API discovery, you have some advantages as well. It is rarely effective to use automated scans to perform API discovery. It is really time saving too, but you have some disadvantages as well. The scanners that you use don't have a context on the application where you're searching for APIs. So you must be aware and keep in mind that you might have some false positives on the way. And besides, the scanner depends on updates. So I advise you to update the tool, the scanner, on a regular basis. So at the end of the day, which is the best option? In practice, a balanced approach that combines both manual and automated discovery might be the most effective strategy. Manual validation can follow automated scans in order to ensure accuracy and address any nuances that the scanner might miss. Besides, identifying all the APIs within a complex system might be a very challenging task. So in order to identify all the APIs that you want to, you should always consider using a combination of automated scans and manual validation. Well, now that the API discovery phase is done, let's go to the documentation. So how to document all the APIs. API documentation, what for purpose? At its heart, the key for API discovery success is essentially the same as a successful API documentation. The two can even be sometimes be handled at the same time, and you can think of them as being part of the same process. API discovery will help users find your API, and proper documentation will show them how to use your API once it is been found. Well, API documentation comes in various types, each serving a specific purpose and public. So according to my experience, I enumerated some key points that I think a good API documentation should include, namely an overview of the API, a quick guide slash getting started guide, authentication information, information about endpoints, request and response formats, parameters, information on the status codes that you might be expecting when using the API, information on the version of the API, testing instructions, contact information, of course, in case the consumers that are using the API have any doubts related to it, use cases, and if you want to, some performance and best practices. An element in the context of API documentation is an API reference documentation. Basically, an API reference guide is a human-readable document that provides detailed information about the API. It provides technical details about the APIs, for example, the methods, parameters, responses, status codes, among others. Here, the public are developers, pentesters, and any consumers of your API. It can be easily generated with a tool like Swagger UI based on the OpenAPI specification. But what is the OpenAPI specification? The OpenAPI specification, formerly known as Swagger, is a powerful way to document your APIs in a standardized and machine-readable format. OpenAPI provides a standard way to describe REST APIs. Besides being used to generate documentation, it can be also used in providing mock servers, performing API testing, and also to help you on API governance checks. Well, sometimes the concept of Swagger and OpenAPI specification is used interchangeably, but in practice, the concepts are really different. So the Swagger is the original project name. It's the name of the toolset. The last version of Swagger is 2.0. OpenAPI specification is an evolution from Swagger and now is a standard for describing REST APIs. In summary, there was a transition from Swagger to OpenAPI specification, and this transition was driven by a desire to create a standardized, open, and collaborative framework for describing REST APIs through the adoption of the OpenAPI initiative. Another concept related to API documentation is what I like to call API Atlas, but in reality are the API marketplaces. And an API marketplace basically is a large platform that houses multiple APIs and allows developers to discover, evaluate, and integrate APIs. And it also includes API documentation as part of the package. An API marketplace brings API buyers and sellers together in one platform. To make this simpler, you can think of an API marketplace like an e-commerce website like Amazon. If you want to sell, for example, your ebook, you can list it on Amazon and all the book lovers can view it and buy it. Similar to this, an API marketplace allows the API providers to list their APIs and monetize them by offering different subscription plans. You have a lot of API marketplaces. Here in the screen, you can see the marketplace from Rapid AI, API, but you have also API marketplaces from IBM, Nordic APIs, Red Hat, among others. So now that the API discovery and API documentation phases are done, it's time to answer the $1 million question: how to identify all the APIs hidden in plain sight. And I don't have only one answer for you, I have 5. So let's see them, shall we? First, use manual methods, use browser developer tools. Besides manual methods, use also automated tools in order to help you with the API discovery task. Analyze source code, explore web pages, perform security testing, pen testing. This is really, really important. Check for API documentation, OpenAPI specification, and other public repositories that might exist about that API. And last but not least, engage with development teams, collaborate with other teams inside your organization, with other colleagues, and if applicable, collaborate with the community. This is really, really important. Well, now what's next? According to the 3 pillars of API security, the next phase is testing. But API security is a continuous and evolving process due to the dynamic threat landscape, changes in API lifecycle, among others. So it requires ongoing monitoring, adaptation, and collaboration in order for you to maintain a strong security posture through the API lifecycle. In essence, you need to constantly and continually depend on these 3 pillars to secure one of your most important assets, your APIs.